So we've seen the imaginary number I and how to form complex numbers, how to add, subtract, multiply and divide them algebraically. A really important part of complex numbers is learning to visualize them. To do this, we need to formulate what's called a complex plane. The trick to formulating the complex plane is to think of a complex number as a pair of real numbers. So if we look at the number z equals x plus iy, the pair of real numbers x and y are forming the complex number z. This means that we can visualize the complex number in a plane where x is the real coordinate and y is the imaginary coordinate. Let's have a go. Let's start with a real number line, and orthogonal to that I'll place an imaginary axis and then I'll tick off numbers on here. On the real number line we can tick off numbers in the usual way, and for the imaginary axis we can tick off units of I. 1i, 2i, -i, -2i and so on. And these we will have equidistant along this line with the number I 1 unit up the imaginary axis. I'm going to label these points I and 2i. You'll sometimes see these labelled 1 and 2 to represent the number of units along the imaginary axis. I prefer to label point I and the point 2i, as I'm also labelling the point 1 and the point 2 and so on. On this complex plane then we can write down numbers like 1 plus I is here, 3 plus 2i is over here, or -3 minus I, and so on. Since we've looked at conjugates, let me also write down the conjugate of a number. Let's do the conjugate of 1 plus I, that's 1 minus I, so that's down here. And let's try the conjugate of -3 minus I, that becomes a number -3 plus I. And in fact, in general, the conjugate is a reflection in the real axis. Once we have the complex plane, we can actually see that addition is the same as vector addition in 2 dimensions. Let's take the numbers z and w, arbitrarily placed here. Now, to add those as if they were vectors, I would use the parallelogram rule, drawing a line from the origin to z and the line to the point w, and then reproducing those lines as a parallelogram to give me a point somewhere here for z plus w. So visually it's the same as adding vectors. Similarly for subtraction.